All right, we're going to talk about vectors. So you know about vectors, some of the stuff about vectors. I'm going to fly through this fairly quickly because you already know this from physics, but some of it is new. So the first thing is just to understand what is a vector. And a vector is a quantity that has both size, that is a magnitude, and a direction. So it's opposed to a scalar, which just has magnitude but not direction. And you guys, that should be review, I think, from physics. So you would have talked about things like velocity versus speed. So velocity is a vector because it has a size and it has a direction, whereas speed is a scalar because speed is just size. In fact, speed is the scalar that's associated with velocity. For notation, when we're talking about vectors, we write them in any one of three ways. You will see this used most often OA with a little vector on top. That's how we're going to indicate them generally. If it's not that, then you'll see sometimes in textbooks, instead of writing this out every time because it's hard to get that little arrow on top when you're using typing, they just bold the letter. And then the magnitude, to get that, you again should have seen this in physics. The magnitude is the absolute value bars around the vector. Okay, so when you write out a vector, you indicate it by using a little vector on the top. When you did it in physics, you would have done things like force, acceleration. Those things all have vectors on them. Now, you didn't necessarily write them out, but you would have done something like this, where you go F, and you'll see a little vector over top. And then it equals MA, and you'll see a little vector over top of the A. All right, now you didn't normally see that. What you normally see is just F equals MA. But that's the notation. All right, so then we get into just concepts of equal and negative. What are those? We're just trying to define things. Okay, so we've defined what a vector is. We've defined what magnitude is. Vector equality is, I mean, if two things are equal, you know that what that means. But in terms of vectors, both the magnitude and the direction have to be equal in order for the vector to be considered equal. So you could have a vector that is equal in magnitude but different direction. It's not equal. And then vectors, the concept of a negative vector, if you're subtracting, it's a little bit different. So we're actually adding a negative. And the negative vector is a vector that has the same magnitude but the exact opposite direction. So if this vector here is going A to B, and let's say that's a 30-degree angle, then this would be coming down at a 30-degree angle from the horizontal. So that's the concept of a negative vector. Then we get into things like vector addition. If you want to show it, you guys would have done these things where you drew vectors. Most of what you did was vector diagrams that were right angles. So you would have said somebody walks, east, and then they walk north. Whoa, that is not straight. And when you do that, you'll see, okay, now we have a right angle triangle, and you would have solved them. That's what you did when you were doing vectors, if you remember. Again, not straight, but I'm trying my best. So you kind of draw the displacement in there, and there we go. Things are going a little crazy here this afternoon. There we go. So you remember drawing diagrams like that, hopefully. What we're going to do when we add vectors is we're going to add tail to tip, or tip to tail, depending on how you want to say it. But the tip of the second one goes on the tail of the first one. All right. I said that backwards. The tip goes on the tail. All right. And in terms of actually working it out, we'll talk about how to do that. But when you draw negative vectors, you're going to do something very similar. You're just going to change the direction. When you draw a zero vector, you don't have a magnitude or direction. It has to be defined, though, because when we go to subtract vectors, you have to have some context of what does zero mean. If you guys remember from last year, you would remember factorials, hopefully, and 0 factorial is defined as 1, even though it doesn't really mean anything. So because we have to have it, because if we take 10 factorial minus 10 factorial, it has to be something. So we have a 0 factorial. And it's the same thing here. We have a 0 vector. And it just is the result of adding a vector and its negative. Okay. So then we talk about scalar multiplication. What does that mean? Again, these are all just definitions. We're going to talk about how to do them, the mechanisms of doing them in a minute, but how to do it necessitates you knowing what it is. So scalar multiplication is multiplying a vector by a scalar. We said a scalar is just a number, right? It doesn't have a direction. So if you multiply it by 2 or by 3, you can see by the diagram that you essentially end up just adding them one at a time. And if you multiply by a negative, then it switches the direction. Okay, so here's a little summary of that. But basically, if k is bigger than 0, then ka and a have the same direction, whereas if k is less than 0, then they have opposite directions. And ka is just, it's twice the size or 3 times the size of a, whatever that vector happens to be. So then we got to talk about, okay, well that's good, but how do I actually do them? And so what we do is we define a vector. This is called component form. It's a way of writing out vectors. Okay, so we write the x component and the y component in a matrix. So you'll see vectors that are written like this. Now, sometimes they use round brackets instead of square brackets. Sometimes you will also see it. There's another form that uses unit vectors, and we'll talk about that a little bit later. But generally, it goes x and then y. And when we start to do operations, it's pretty easy to then write out, here's the operation. So the actual mechanism of vector addition is to take the components, the x components and the y components, and then add them together. Again, components should not be something that's foreign to you, because in physics you would have done this. So you remember when you did inclined planes, for example, you would have drawn, and again, you'll have to bear with me whether this will actually look like an inclined plane, but you would put the box on the incline, if you remember doing these, and again, you may not, but hopefully you do. And then gravity, I put my box on my incline, gravity always acts straight down, right? So we have this gravity acting out and gravity acting straight down, and then this out like that. If you remember that, we'd find FGH and FGV. Again, this might not make any sense to you if you don't know what I'm talking about with physics, but if you do, you remember splitting it into components. And we did that for momentum. We do that for all sorts of things in physics. So it's a very similar concept. You remember, FGV was FG sine theta and FGH is FG cosine theta, or the other way around, depending on where the theta was. So you can look at components the same way as we did in physics, but when we did it in physics, we didn't necessarily write them out as a matrix. Here we do. So you're going to see a lot of this, and then to add them, it's just a matter of adding the components. Very easy to do. So in other words, if I give you, let's say for example, and this is just a very simple one, but let's say for example, I said I want A to be 2, 3. Whoops, I don't need, just a second. I don't need that bracket in there. So 2 and 3, and then let's say B is, oh, why that's doing that. 1 and 4, there we go. So then A plus B, this becomes 2 plus 1 and 3 plus 4. It's very simple. Even though trying to get to write down doesn't appear to be simple this afternoon, my hardware is malfunctioning. But there's the example. That's just what you do. And if you were subtracting, all right, so if you went A minus B, you would just go 2 minus 1 and 3 minus 4. All right, keeping in mind that that means what we're really doing is adding the negative. Okay, so your result would be 1 and minus 1. So that's vector addition and subtraction. Very simple concept if it's in component form. Okay, so there's our vector subtraction. And it's exactly what I just showed you, so you don't have to write it down again necessarily if you don't want to, but that's what vector subtraction does. It subtracts the components instead of adding them. Now we're going to talk about 2-dimensional versus 3-dimensional vectors. We're going to talk about both kinds. So we are going to add a component, but if we add a component, we just do the same thing. It's just A3 minus B3 if we had a third dimension, okay? And A3 plus B3 if we're doing vector addition. And then scalar multiplication, when you do that, you just literally multiply each component by the number. Okay, so if the number is 3, then it becomes 3a and 3a for each of the components. Okay, And then I've just noted down here that if you multiply it by -1, you end up with a negative of a, which we kind of know. And if you multiply it by 0, you end up with what we defined as the 0 vector. So that's scalar multiplication. That stuff should be not new to you, not the concepts. You should have some concept of that. All right, and then this is the final thing that, again, you should not see and be confused by. This is the length of a vector, which is the magnitude of a vector. And in general, it's just the square root of the components squared and then added. So it's the sum of the square of the components square rooted. All right, so for example, if that's 2 and that's 3, then it's just 2 squared plus 3 squared square rooted. It's just a Pythagorean theorem. And you did this with vectors in grade 11 a lot. So not a new concept, but we're just kind of reminding you and laying the groundwork kind of at the same time to make sure you understand those things, right? And then you can use these things to find the distance between 2 points by finding the vector. So you can use just these concepts, scalar multiplication, addition, subtraction, to do certain things. And so here's one of the things you can do. You can find the distance between 2 points. So what you do is you write in the 2 points as 2 vectors that originate from the same point. So it says if P is this and Q is that, then we're going to start at P and go to Q, right? Because we want the distance from P to Q. In the second part, we're going to find the vector PQ, all right? And so to do that, we subtract, okay? We go Q minus P, and it's important that you know that, okay? So it's noticed over here, it's put right here, and it's important to understand that the second letter, that component comes first minus the first letter's components, okay? So when it's written as PQ, it's Q minus P, all right? And then once you've found that vector, you find the distance by finding the magnitude of that vector, okay? But it's just understanding AB and BA then mean different things. They're opposites. So I'm going to just stop the video there, and then we'll start another video to talk about some other things. But those are just hopefully all just review things for you.